Yes, it is a lecture for questions for competitive exam, Neet JEE. We will start from electrostatics. Electrostatics means behavior of stationary charge. Okay, in your NCERT textbook, it is chapter 1 and chapter 2. Chapter 1 electric charge and electric fields, and chapter 2 that is electrostatic potential and capacitance. So yes, under electrostatics we will see these two chapters. Okay, yes, it is a quick revision to solve some MCQs. See, it is quick revision. Electric charge, it is property of matter due to which it produces and experiences electric and magnetic effects. Yes, you know about it. SI unit of charge is coulomb, its CGS unit is state coulomb or electrostatic unit, and its electromagnetic unit is AB coulomb. What is relation between them? 1 coulomb is equal to 3 into 10 raised to 9. State coulomb is equal to 1 upon 10 AB coulomb. Next one is quantization of charge, that is Q is equal to plus or minus NE, where E is equal to 1.6 into 10 raised to minus 19 and N means integer. Okay, yes, plus or minus. Why plus or minus? Because there are two types of charges, positive charge and negative charge. Here we will consider charge on proton, positive, charge on electron, that is negative. Okay, so yes, what is electric charge? Quantization of charge. Law of conservation of electric charge, that you already know. Okay, yes, algebraic sum of charge before and after any process, it remains constant. Next one is Coulomb's force. Coulomb's law. Coulomb's law is for stationary point charges. Coulomb's law is for stationary point charges. See, we know already what is Coulomb's law. Okay, yes, we know what is Coulomb's law, but now we will see different equations. Here it is. We know what is Coulomb's law. Coulomb's law is, okay, yes, force acting between two stationary point charges, is directly proportional to product of their charges and inversely proportional to square of distance between them. If we remove proportionality, we have to add some constant. So F is equal to K Q1 Q2 upon R square, where K is Coulomb's constant. This K is Coulomb's constant. Yes, this K is Coulomb's constant. Its value is 9 into 10 raised to 9. Yes, its value is 9 into 10 raised to 9. Or I can write is equal to 1 upon 4 by epsilon 0 Q1 Q2 upon R square, where this K Coulomb's constant is replaced by 1 upon 4 by epsilon 0. So yes, you have to remember Coulomb's constant K is equal to 1 upon 4 by epsilon 0 is equal to 9 into 10 raised to 9. Okay, 1 upon 4 by epsilon 0 is equal to 9 into 10 raised to 9. Yes, this equation is for when two charges, medium between them is air, separated by distance r. Medium between them is air. Air is dielectric medium. Yes, it is dielectric medium. So yes, between two stationary point charges, medium is air. Then we have to use this equation. Now if, see, as shown in figure, two same charges Q1 and Q2 separated by distance r, but medium between them is replaced by another dielectric medium having dielectric constant K. Now this K is dielectric constant. This K is dielectric constant. Okay, so yes, see, the whole space between Q1 and Q2 is replaced by dielectric constant. Then what is equation? Yes, F is equal to 1 upon 4 by epsilon. You have to replace this epsilon 0 by epsilon. So 1 upon 4 by epsilon Q1 upon Q2 R square is equal to 1 upon 4 by epsilon 0K Q1 Q2 upon R square. Here I can write Fm. Fm means force acting in medium. And what is the relation for that? Yes, Fm is equal to F upon K. When this air totally this region is replaced by dielectric medium. Clear about this? Now next case, if the region between two charges is partially filled by another dielectric. See, here it is if thickness of this dielectric is T, thickness of this dielectric is T, and it is placed between these two same charges, then now see, here it is clear, here it is clear. In this region it is another dielectric, while in this region it is air. Yes, in this region it is air, in this region it is air. Yes or no? Yes. Okay, so yes, for this condition, if another dielectric having thickness T and distance between two charges is R, then what is equation? F is equal to 1 upon 4 pi epsilon 0 Q1 Q2 upon R minus T. R minus T, because in distance R minus T is F plus T root K, where K is dielectric constant, where K is dielectric constant. And you know, yes, for vacuum K is equal to 1. For air it is nearly equal to 1. Yes, it is nearly equal to 1. Okay, for another dielectrics it is greater than 1. It is greater than 1. K is greater than 1. And for metals, conductors, that K is equal to infinite. That K is equal to infinite. Clear? So yes, this K means dielectric constant. Yes, this is new equation for you. Okay, that you have to remember. Vector form of force, that is F12 is equal to 1 upon 4 pi epsilon 0 Q1 Q2 upon R12 square R12 caret. Okay, and yes, this line, force acts on line joining two charges. Force acts on line joining two charges. Plus, you also know that between two like charges there is repulsive force, and between two unlike charges there is attractive force. Yes or no? Yes, it is. So, it is basic about electric charge and Coulomb's law. Now, we will see some questions based on it. Okay, see, a charge Q is placed at each of the opposite corners of a square. A charge Q is placed at each of the other two corners. If the net electrical force on Q is 0, then Q upon Q equals 2. See, first of all, we will draw a square. Let it is a square having side L. Okay, let it is named A, B, C and D. Okay, a charge Q is placed at each of the opposite corners. Let on this and this Q, and here it is Q. Okay, and at other two corners it is small q. So here it is small q, and here it is small q. Okay, now yes, you have to find if the net electrical force on capital Q is 0, then Q upon Q equals 2. Now, capital Q means like force acting on this charge. This charge means on A. So, on this charge, force is acting due to other charges. Yes or no? So, yes, force acting on A, Fa is equal to 0. Force acting on A is due to, force acting on A is due to, yes, it is due to B plus C plus D is equal to 0. Is equal to 0. Clear about this? Force acting due to B plus force acting due to C plus force acting due to D is equal to, it is 0. Now, we have to see direction of forces. Yes, we have to see direction of forces. See how it is. It is like this. FD, FC, FD, force acting on A due to B. This Q charge and this Q charge. Okay, yes. Charge is Q, it is small q, distance between them is L. For FC, it is Q and it is Q. Distance between them, this distance, it is root 2L, as it is root 2L. And for FD, it is Q, and distance between them is L. So first of all, you have to identify pairs. Okay, first, second, and third one. Okay. Okay. Now force acting on this Q is 0. It means FB plus FC plus FD is equal to 0. So yes, if I want to write this equation, how to write? Yes, I can write this equation as it is FB plus FD is equal to minus FC. Is equal to minus FC. Means resultant of FB plus FD and FC, they are of equal magnitude but in opposite direction. They are of equal magnitude but in opposite direction. Clear about this? Okay, so yes, first of all we will find what is resultant or magnitude of FB and FD. We will find what is magnitude of FB and FD. See, FB means force acting on A due to B, and force acting on A due to B. So see here, FB is equal to FD. Their magnitudes are equal. Why their magnitudes are equal? Because on A, force acting due to B, Q and Q, charges, distance L. Q and Q, charges, distances L. So what is equation? This equation is, it is 1 upon 4 pi epsilon 0 QQ upon L square. Their magnitudes are equal. But what about the direction? What about the direction? Yes, force acting due to B, it acts on this line. And force acting on A due to B, it acts on this line. Means they are perpendicular to each other. They are perpendicular to each other. Okay. Okay, they are perpendicular to each other. Force acting on A due to B, it acts on this line. Force acting on A due to this charge, it acts on this line. So yes, these two forces are normal to each other. FB and FD are normal to each other. Normal to each other. So according to law of parallelogram, their resultant, that is mode of FB plus FD is equal to under, it is FB square plus FD square plus 2FB FD cos 90. And we know that cos 90 is equal to, it is 0. Okay, but FB and FD, they are having equal magnitude. So I can write it is root 2. It is root 2, 1 upon 4 pi epsilon 0 QQ upon L square. Okay, so it is mode of this equation. Okay, mode of FB plus FD. Now what is mode of FC? What is mode of FC? Mode of FC means magnitude of force acting on A due to C. Yes, it is simple. It is 1 upon 4 pi epsilon 0. 1 upon 4 pi epsilon 0. QQ divided by what is distance? It is, what is distance? It is root 2L whole square. So I can write it is 1 upon 4 pi epsilon 0. It is Q square upon 2L square. It is Q square upon 2L square. It is Q square upon 2L square. Clear about this? Okay, so yes, now see what is meaning of this equation. Meaning of this equation is FB plus FT is equal to minus FC. Means that magnitude equal but direction opposite. Magnitude equal but direction opposite. So from this equation, how to write? Mode of FB plus FT is, here it is, root 2 1 upon 4 pi epsilon 0 QQ upon L square is equal to minus, what is magnitude of FC? Yes, it is 1 upon 4 pi epsilon 0. It is Q square upon 2L square. So 1 upon 4 pi epsilon 0, 1 upon 4 pi epsilon 0, 1Q, L square cut. Yes or no? We have to find ratio Q upon Q, capital Q upon Q. So yes, here it is capital Q. The small q this side, it is minus sign, this 2 in numerical, and here it is 2. So Q upon Q is equal to, it is minus 2. Q upon Q is equal to, it is minus 2 root 2. Means, if one charge is positive, then another charge is negative. If one charge is positive, then another charge is negative. Clear about this? So yes, it is one question. Yes, as I have to explain. I have to write this each and every term in detail. But yes, some steps you can write directly. Okay, this term you do not have to write. This term you do not have to write. Okay, yes, you have to remember this equation. okay, when two forces are of equal magnitude, then the resultant is, and if they are normal, then the resultant is it is root 2. Then the resultant is it is root 2. Okay, then yes, how to put values in this equation? Clear about this? Okay. Now next question. See, two balls carrying equal charges are suspended from a common point by string of equal length. The equilibrium separation between them is R. Now the strings are rigidly clamped at half the height. The equilibrium separation between the balls now become. See what is question here is. Two balls carrying equal charges are suspended from a common point. For example, if we have two balls like this. If initially there is no charge on them, no charge means no electrical force, means they will be like this. But you see what is given? Two balls carrying equal charges. So if charge on this is Q and charge on this is also Q, then due to like charges there is repulsive force between them and they will move away from each other. Yes, two balls carrying equal charges are suspended from a common point by strings of equal length. The equilibrium separation between them is R. They are not like this. The equilibrium separation is R like this. See. The equilibrium separation is like this. Okay, distance between them. Distance between their center is R. Clear about this? And yes, this height is y. This height is y. I am assuming you are given only this distance r. This is y I am assuming. Okay. The two balls carrying equal charges are suspended from a common point by string of equal length in equilibrium. The separation between them is r. Now the strings are rigidly clamped at half the height. The equilibrium separation between the balls become. See what is question. Okay, now these two strings are rigidly clamped at half of the height. Then now what is distance? Two spheres are same. Okay, two spheres they are same. Now your question is what is the equilibrium separation? R dash is equal to what? R dash is equal to what? Clear about question? Hello? What is question? Clear? Okay. So yes, it is question. Initially this height is y. Separation between them is r. Now two strings are clamped at half of the height. Half of the height means now this height is y by 2. This height is y by 2. Clear about this? Okay. Then yes, you have to find what is equilibrium separation. Now see here. When two spheres, two balls having same charges, they are in this condition, then numbers of force acting on them. First, due to mass of each sphere, mg, it is acting in downward direction. These two spheres are moving away due to electric force. Yes, these two spheres are moving away due to electrical force, that is Fe, and Fe, it is in this direction. We have to draw free body diagram only for one sphere, because for another sphere it will be same. Okay, and then as it is string, so tension is in. Let it is y. This distance you are given, it is r. Okay, so obviously this distance is r by 2. It is height y. I am assuming this angle theta. So yes, mg in vertical plane, Fe in horizontal plane. You have to resolve this t in two components. This angle is theta. Obviously this angle will become theta. So it is t cos theta, and this component will become t sin theta. It is t sin theta. Clear about this? Yes, it is t sin theta. Now as the system is in equilibrium, so for equilibrium condition, how to write? See, Fe is equal to t sin theta. Fe is equal to, it is T sin theta. Similarly, mg is equal to T cos theta. Mg is equal to T cos theta. If you take the ratio, then yes, you will get Fe upon mg is equal to, it is tan theta. Fe, electric force between two spheres. See, charge on this Q, charge on this Q. Distance between them is r. So I can write it is 1 upon 4 pi epsilon 0 q square upon r square. Here it is mg is equal to tan theta. Yes, what is tan theta? What is tan theta? Yes, see, angle theta, and this distance is r by 2. So tan theta means it is opposite side upon adjacent side. So tan theta means it is r by 2 upon y. Yes, it is r by 2 upon y. Clear about this? It is r by 2 upon y. Now understand question. Initial height is y, then separation is r. In this case, height is y by 2, then what is separation? So yes, you have to obtain one relation between r and y. You have to obtain one relation between separation r and height y. Separation r and height y. So yes, r and y. So if here I make r as subject, okay, see how to make r as subject. Here it is 1 upon 4 pi epsilon 0 as it is, q square as it is, mg as it is. Okay, r square I will bring this side, means it is r cube. Yes or no? 2y here this side. Any doubt? So it is 1 upon 4 pi epsilon 0 q square 2y upon mg is equal to r cube. Now see another terms. 1 upon 4 pi epsilon 0 constant. Charge on sphere constant. 2 constant. M constant. G constant. So yes, you can write here, okay, r cube is proportional to y. R cube is proportional to y. Yes or no? Yes, it is. R cube is proportional to y because all another quantities 1 upon 4 pi epsilon 0, q, 2, m, g, they all are constant. They all are constant. So yes, you can write r cube is proportional to y. So r is proportional to y raised to 1 by 3. Y raised to 1 by 3. So now, how to relate this? See, r dash upon r. R dash upon r. R dash upon r is equal to, in this case, what is height? It is y by 2. In this case, what is height? It is y raised to 1 by 3. Raised to 1 by 3. Clear about this? So yes, this y cut, okay. Then r dash upon r is equal to, it is 1 upon 2 raised to 1 by 3. Yes, now make r dash as subject. Then what is r dash? Yes, r dash is equal to, it is r upon 2 raised to 1 by 3. R dash is equal to r upon 2 raised to 1 by 3. So yes, you can say this is your answer, or you can also write this answer as r 1 upon 2 raised to 1 by 3. R 1 upon 2 raised to 1 by 3. Clear about this? So yes, these are some questions based on electric force. Okay. See, next question. Two charges each equal to q are kept at x is equal to minus a and x is equal to a on the x-axis. A particle of mass m and charge q0 is equal to q by 2 is placed at the origin. If charge q0 is given a small displacement y is very small than a along y-axis, then net force acting on particle is proportional. See what is here. You are given x-axis. You are given x-axis. It is origin. One charge q is placed at x is equal to a. X is equal to a, and another at x is equal to minus a, means another charge q is placed this side at distance a. Distance is positive. This minus a and plus a. It is given that one is on right hand side of origin, another is at left hand side. But distance is always positive. Okay. Yes. A particle of mass m and charge q0 is equal to q by 2 is placed at origin here at this point. Okay. Now if charge Q0 is given a small displacement, y is very less than a on y-axis. Let it is y-axis. So let it is given a small displacement. Means charge Q0 will be here, a small displacement y. A small displacement y. Then your question is, the net force acting on particle is proportional on this particle. Force acting is directly proportional. So yes, you have to find force acting on this particle. How to find? Chalo. Force acting on Q0 particle. Yes, like charges. Okay, very simple question. Force acting on Q0 is due to this Q charge and due to this Q charge. Okay, see, Q, magnitudes are same. This distance, they are also same. Due to this particle, force acting on Q0, it is repulsive and it is along line joining, means in this direction, that is F. Simple. Force acting due to this Q charge on this, it is F in this direction. Why F and F same? Because these two charges are same and these two distances are also same, so magnitude of these forces are also same. Clear about this? Okay. Now we have to resolve these two forces. One in horizontal direction and one in vertical direction. It is charge Q0. Okay, it is charge Q0. Okay, so yes, we have to resolve this force into components, one horizontal, one vertical. Now to resolve forces, we need to resolve factors, we need angle. I am assuming that this angle is theta. Let this angle is theta. So obviously this angle will become theta. So this component will become F cos theta and this component will become F sin theta. Similarly, I have to resolve this force into components, one in this direction, another in this direction. Yes, similarly this angle will be theta. It is theta. So this component, it is F cos theta. This component, it is F sin theta. From figure it is clear. Okay, two F sin theta components, they are in opposite direction. Two F sin theta components, they are in opposite direction, so they will cancel out each other. So at this point, resultant force on particle. Yes, the resultant force on particle F dash is equal to, it is F cos theta plus F cos theta, means it is 2F cos theta is equal to 2. F means force acting between these two charges or these two charges. What is equation of force? It is 1 upon 4 pi epsilon 0. Force charge of this particle is Q and here charge is Q0. So yes, here it is Q0. Okay, so 1 upon 4 pi epsilon 0 Q. What is this distance? This distance, it is A, it is Y. So yes, it is obviously under root y square plus a square. So yes, it is under root y square plus a square whole square. Any doubt? Cos theta, yes, from figure you can also write cos theta. Cos theta means adjacent side upon hypotenuse. So cos theta, its adjacent side is y and hypotenuse is, yes, it is under root y square plus a square. So now how to simplify this? F dash is equal to 2. 1 upon 4 pi epsilon 0. Q0 means you are given it is Q by 2. Here it is y. Divided by y square plus a square, its square root and its whole square. So yes, this square root and whole square cut, then it is under root y square plus a square and here it is y square plus a square. So it will be y square plus a square, which will be 3 by 2. Clear about this? So yes, it is the whole equation for force. It is the whole equation for force. F dash is equal to 2, 1 upon 4 pi epsilon 0, Q by 2, y square plus a square is to 3 by 2. But you are given one condition, that is y is very less than a. Y is very less than a. So with respect to a, you have to neglect y. So in this denominator, this y square you have to write 0 with respect to a, not this y, okay, not this y. So this equation will reduces to this equation now becomes, see, it is f dash is equal to, 2 1 upon 4 pi epsilon 0 q square upon 2. Here it is y, and in denominator it is only y square is equal to 0. Then a square raised to 3 by 2. A square raised to 3 by 2. So this square by 2. Okay, cancel. Then it is AQ. Now we have to find the force is proportional to 2 constant. 1 upon 4 pi epsilon 0 constant. Q constant. Y. Yes, y, that is displacement. A, that is distance between two charges, constant. So here we can write f dash is proportional to y. F dash is proportional to y. Simple. Okay. So first of all, you have to draw diagram properly. Okay, and then you have to find what is resultant force acting on it, and how to make relation. F dash is proportional to y because another quantities are constant. Clear? So yes. There are numbers of questions based on Coulomb's force. Okay? For today, this is it.